Here we go then, folks. We're taking the idea of factorising one step further. We're looking at these things we call quadratics. You've seen this arrangement before. There's an example of x squared plus 3x plus 2. It's a quadratic, or it meets the requirements of a quadratic if the biggest term in it is an x squared term in it. 2x squared is fine, 3x squared is fine, etc. But if you've got an x cubed, then no, that isn't a quadratic anymore, and you can't use this system. But we have come across these before. Let's look at how we generated some and what we can do so far. Let's remind ourselves what we've seen is the idea of expanding and factorising being the opposite of each other. So let's take an example. It goes brackets 3 multiplied by x plus 2. We've done this sort of thing before. We go 3 times x and we get 3x, and we go 3 times 2 and we get plus 6. And that was expanding, and we're pretty good and pretty comfortable at that. Factorising, remember, was doing the same thing in reverse. So we'll write down what we just finished with, 3x plus 6. Factorising is saying, well, what are we going to put inside the brackets? What are we going to put outside? We look at our 3x, we look at our 6, we say, oh, the common factor here is a 3, no problem. Then we say, what are we going to multiply our 3 by to get 3x? And the answer is x. What are we going to multiply our 3 by to get 6? And the answer is 2. So factorising and expanding were opposite to each other, and we're pretty good, we're pretty comfortable. I don't think that's too stressful for us. Let's look at another variation on the theme we did when we were expanding. It was the situation we've seen where you had two lots of brackets. Here's my example. It goes x plus 2, and we multiplied all of that by everything in the second brackets, which in this case is x plus 1. If you cast your mind back, the way we did that was we used the process I called FOIL, first, outside, inside, last. Let's see what we get. The first bits are the x, and that gives us, when we multiply them, x squared. The outside is the x and the 1. Multiply those together and we get x. The inside is the 2 and an x. Multiply those together and we get 2x. And the last bit is the 2 and the 1. Multiply those together and we've got ourselves 2. We can combine these bits in the middle. Let's simplify it up. X squared plus 3x plus 2. That was expanding two brackets. You're comfortable with it. We use the process called FOIL. Factorising, we just said that was the same process but run backwards. Let's have a look at it. It goes, here's the question, x squared plus 3x plus 2. What we're asked to do is factorise it. Okay, a couple of things you can always do at the beginning. If you're factorising a quadratic, it's going to end up in this form with a couple of brackets. You know and I know that they're multiplied together. In this situation, the two things are going to multiply to give us x squared, so it's fairly straightforward at the beginning to put an x in at the beginning of each bracket. That shouldn't be controversial. The other thing we can do in this sort of situation is we've only got positive signs, so let's just chuck in a couple of positive signs. So far so good, we haven't had to do much thinking. Okay, here goes the challenge. What we need is to think of two numbers that will multiply together to give us the number 2. And you really haven't got an awful lot of choice. They're going to have to be the number 2 and the number 1. They multiply together to give us the number 2. Now we also need to check that the same two numbers will add together to give us 3. And amazingly enough, 2 and 1 do that. So we can put a 2 in here and a 1 in here. It doesn't matter which bracket they go in. And as you can see, that gets us back to where we started with. So we've factorised by saying what we're looking for is two numbers that multiply together to give us the number at the end, and they add together to give us the number in the middle. That's going to be the rule and the arrangement with factorising. Here's an example. We'll just quickly run it through. I'll jot it in place for us. Here's an example. It goes x squared plus 9x plus 14. Again, follow the rules. Put in your double set of brackets, that much we can always do. Put in an x, that much we can always do. Check that we're only dealing with positive signs, and we are at the moment, so put those in as well. Okay. What we need is two numbers that multiply together to give us 14. Well, there's 1 and there's 14. They multiply to 14. There's 2 and there's 7, and I can't think of any more. Those things multiply to give us 14. We're going to need two numbers that add together to give us 9. Well, there's 0 and 9. There's 1 and 8. There's 2 and 7. Oh, I'm going to stop there because I've found two numbers that appear on both lists. 2 and 7 seem to be the answer. As I say, it doesn't matter which order we put them in. We think, therefore, that the answer to our question is we factorised it down and we think the factors are x plus 2 and x plus 7. smart money, and many of you guys have already realised this, is it's a great idea to do a quick check to see if we've got our answer right. We can do that by re-expanding. X multiplied by x gives us x squared. X multiplied by 7 gives plus 7x. 2 multiplied by x gives plus 2x. And 2 multiplied by 7 gives plus 14. These bits combine. When we simplify it up, x squared plus 9x plus 14. Yes, we've come full circle because we can factorise a quadratic. Let's remind ourselves from the beginning, it's a quadratic if it's got an x squared term in. Typically that's then got some numbers of x's and then some numbers of numbers. We were doing the expansion, that's where you did FOIL, and we've no problem. Factorising is the reverse of it. This is the arrangement we're looking for. The two numbers that go in our brackets here, they must multiply to give the n number, and they have to add to give the number that's in front of the x.